Welcome. Today I will be going over my approach to solving Fall 2020 Test 2, Question 5. There exists a solid metal sphere of radius RA with positive charge 2Q. This sphere is centered with a thin spherical plastic shell of radius RB with charge negative Q that is distributed uniformly on its surface. RB is greater than RA. Part 1 asks us to determine the potential difference between the outer surface of the metal sphere and the inner surface of the plastic shell. First, note that at the location RA, the radius of the solid metal sphere, the net potential is the result of the potential contributed by the sphere as well as the potential from the plastic shell of charge negative Q. Thus, VRA is equal to the sum of V1 and V2, where V1 and V2 are the potential contributions from the sphere and the shell, respectively. Remember that the potential at a location due to an external source of charge is equivalent to K multiplied by the charge of the object divided by the distance between the charge or the object and the external source of the charge. Therefore, the potential at location RA is equal to K times 2Q over RA plus K times negative Q divided by RB. VRB is equal to the sum of V3 and V4, which are the potential contributions from the metallic sphere and the plastic ring, respectively, at RB. Thus, RB is equal to 2KQ over RB minus KQ over RB. The potential difference VRA minus VRB is equal to 2KQ over RA minus 2KQ over RB, which is our final answer for Part 1. Part 2 asks us to determine the potential difference between the center of the sphere and infinity. At r equals 0, we will assume that the only potential contributions are from the sphere and the ring. Thus, the potential at r equals 0 is the same as it was in Part A. We will make the assumption that the potential is 0 at a location an infinite distance away from r equals 0. Thus, V0 minus V infinity is equivalent to 2KQ over RA minus KQ over RB. In the last part of the question, we are asked to describe what would happen to V0 minus VRA if we place the two objects in between two large oppositely charged plates. There will be no change in V0 minus VRA due to the superposition principle. The potential contributions from the positive and negative plates would cancel out. Lastly, I will discuss a few modifications you might consider making to this problem during your studying process. What would happen if we wanted to find the potential difference RB minus RA? Would our answers change if we switched the charges on the sphere and ring? Pause the video here to think of your answer. The potential difference RB minus RA will be the opposite sign of our answer from Part 1. Did you get this correct? If not, you might consider reviewing the formula for potential difference. Lastly, if we switch the charges on the sphere and the ring, we would not get the same answer as in Part 1, since the potential contributions from the charges would be at different locations. More specifically, the RAs and RBs in the potential formula would be swapped. Thank you, and good luck on your upcoming exam.